Need to share the screen. All right, so I seem to have I'll just use that Pi 38 ML 2024. Conda activate Pi 38 ML 2024. Really, the only library we need is transformers, which I'll show you how to install if it's not available. And in the background, it still uses PyTorch or TensorFlow. So I usually just use Torch. So if we need to install something, we will. All right, so start a Jupyter notebook. All right, let's go to the desktop here. And 5:30, 2025 spring. So that should be good. Okay. So we're just going to write some scripts here to start playing with transformers. Okay, that's all the goal for today. So I'm going to create a new Jupyter. Sorry. Again, a lot of very powerful models are available, but they're just too big. So they're going to fill up my hard drive and run very slowly and take forever to download. So I'm going to use GPT-2 for all this, but you guys, I encourage you at home to try better models, etc. Okay. So let's just call this one Hello World GPT. And just a very simple example. And all this code is already on the GitHub. So I'm going to go ahead and close this. So I'm going to go here to 2024, and I'm just going to grab this one. See, I have some here, GPU required. All of this stuff here will only run if you have a GPU. Okay. So let's start with this one, Hello World GPT-2, kind of a Hello World example. This one, all it's going to do is we're going to try to ask it some questions, and it's going to generate text, but you will see it's not that great. Okay. But at least it's going to show us the total functionality of GPT. So you will need, if you don't have that, you will need to install the transformers module. So remember, you just do pip install transformers. Okay. And then let's see here. So these are the libraries. So we're going to talk a little bit about how that works. So you can see the library is called transformers, and it's got a lot of modules, right? So it's got one called pipeline, which allows you to define, a lot of things with just that for taking input and producing output. Whenever you download a model, you will see that we need the actual model and the tokenizer, where the tokenizer is the thing that maps numbers to words, right? So in this course, I don't cover like the inner workings of GPT. That's something that I cover in the other course, 520. But if that's fine if you don't remember, if you haven't taken that. But what I'm saying is it's all numbers in the GPT. And then those numbers need to be converted to text, and the tokenizer takes care of that. So you will need an auto tokenizer and some other construct. So let's see if my libraries work. If I have transformers in this one. Okay, so I actually don't have it. So then I'm going to have to install it, which should be efficient. So you can see pip install transformers. We're going to give it a minute there. While it's doing that, I can probably get some more code. So these are some variables for the generation of the text. So we can add it there. And then here, actually we have this. Did it finish? Okay, so let's look at the output. Okay, successfully installed. No red or errors. That's good. I'm just going to comment it out now. And I'm going to load the libraries. So it's processing. Going to give it a minute there. It's happening. I'm going to add this. All right, so no errors, right? So that means the library is loaded correctly. And so essentially the simplest way to get started with transformers is to use this object called the pipeline. So the pipeline allows you to just like very easily set things up. But we'll see that there are other ways where we download the tokenizer and the model and all that separately. Here, we're essentially just saying that we want GPT-2, right? And the pipeline will figure out like what default version of GPT it is going to download. And as I said, the simplest thing is we use pipeline because we can define here one of several tasks that we wanted to perform. So for instance, this one is text generation. We have the model name there. If you wanted to, you can remove this, and then you could also specify a device that you want to use, such as a GPU, a CPU. So I don't have a GPU on this machine, so it's by default going to do CPU. But let's try it. So I loaded the model, as you can see. So, or at least define this object. No issues there. Here's the tokenizer. And then we have this function here, generate examples. So it's this code here. So we pass the generator to it with some parameters. So I'm going to need to use this function. So let's run it first, make sure it works, and then we can talk a little bit about it. Essentially, this function that I'm copying is not really necessary. It's just a way of like making it more in a structured way. Okay, so we'll come back to that. And we've done this. So let's try this idea. Okay, so as you can see here, basically you're providing a list to answer of questions. The first question is, when will it snow this week, right? So that's essentially, you give that to a GPT and it's just going to start generating a sequence, right? That's all it does. And this one is not fine-tuned for question answering. So, and it's a GPT-2, which is not as smart as necessary. So model GPT generator, that's this one here. The list to answer is basically this. So we only ask it one question, and then it's going to generate an output, say something using this code, generate example. So let's go ahead and try it. So it's just doing some internal things there. I'm not seeing any errors yet. More warnings, and you can see it actually worked. So what did it do, though? You can see, when will it snow this week? Answer 1, when will it snow this week? Answer 2, when will it snow this week? And then after this, you see what it generated. So this is the input we gave it, and this is what it said. right? So this is a pre-trained GPT, no fine-tuning, and what GPT-2s were like. So as you can see, GPT-2s were not that impressive. We won't predict how long the snow may snow this week. You can still see when it does, why snow on Fridays. We'll find out more about snow by week here on the website of the Icebreaker Snow and Ice Creamery. In addition to the weather, we'll highlight the weather extremes this summer. Funny or crazy seals. You see that? So not great, you would argue. But actually, this is pretty impressive because it does that. And then through fine tuning and RLHF, you start giving examples of questions and answers. And eventually it starts to get better. That's the breakthrough, basically. So the process also has been studied like this. You go from this. Do you just need fine tuning? That's what people tried initially. That didn't work. Then what about just RL, RL, reinforcement learning through human feedbacks? That also seemed promising, but nobody knew exactly. And I think they don't even know still. Currently, I think the recommended approach is pre-train, SFT, which is supervised fine-tune, then reinforcement learning, and then maybe several cycles of that. Does that make sense, guys? Any questions? So anyway, so this is your first example just to kind of introduce you to the library of transformers. So you can see here, the code in this one is pretty straightforward. In this function, it just takes the generator and a list of prompts. You set a seed value for it, like 42 for randomization, and then for prompt and prompt list. So you could give it essentially multiple questions. So for prompt and prompt list, the generator basically gets the prompt. You see that here, right? So this is the generator, the GPT-2. You get the prompt. You specify the maximum length that you want to generate, the number of return sequences, and then you have your answer and result. This is you create a dictionary, and then from results, basically, this result, you assign it to answer here, and then example basically is a dictionary. So given the prompt, it gets an answer, and then you just save it and display it out. So this just creates this specific format that comes out as a dictionary, essentially. Any questions? So that none of this function has anything really to do with the transfer learning. It's just a way of structuring the data as a dictionary. All right, so for those of you, as I assume sometimes that but a GPT is what? Model that given some text, it just continues to generate more text from that until it reaches some length, okay? So you get, as we saw, we gave it just this one sentence, and then it just generated the next and the next and the next and the next token until it reaches certain thing. So an example of this is if I say the cat is sitting on the what? Chair, table, but not satellite, right? So we know that there's some probability distribution of what the next word is going to be. And that's kind of what, in a high level, what the GPT is learning to do. And then once it gives satellite, that becomes part of the chair. So then it's going to say the cat is sitting on the chair. That output actually becomes input. So the next word is the cat is sitting on the chair and so the cat is sitting on the chair and is, and so on until it produces up to a certain, right? So those are GPTs and so on. So now so that we've done this example, as you can see, that's my hello world to transformers. All right, let's take a look at another one. So I have this. And we will learn that, the 2017 paper, Attention is All You Need, came out that laid out the basic transformer. Then after that, people started to create from those ideas two types of transformers. One called GPTs, as I mentioned, and then one called BERT models, right? So in a future lecture, we'll talk a little bit about, kind of what the BERT model is and how it's different from the GPT. But just be aware of that. Given that these BERTs are actually really useful for RLHF, right? We're going to see that later. These are models that, but in a high level way, I can say a GPT, given some text, it generates more text. A BERT, given some text, it just provides like a class or some specific thing, maybe just one specific token, such as a missing word, or it can say this is a sad, text or a happy text or something. So let's take a look at another example. This time, we will be running BERT models, basically. BERT models, it's an acronym, bidirectional something. Who knows one? Yeah, bidirectional encoder transformers, something like that. So, but whereas GPTs just go in one direction, right, and they never look at the next token, BERT models actually look at things to the left and the right, and they kind of just learn like missing words. So we'll see this in an example. So let's go ahead and run a BERT model here. So I'm just going to say BERT. So BERT model. All right. And although all of these are transformers models, the transformers library has created a lot of abstractions for the type of model they are. So for instance, there's an abstraction for BERT models that are actually Albert models. And so they have this Albert tokenizer Albert model because this is designed just for that very particular structure, okay? And again, you could do this in pure PyTorch, but this is meant to be easier in a sense, okay? All right, so let's go ahead and do that. So I'm going to run the libraries and see if we're missing any and just install them. All right, so actually nothing is missing. Okay, so we've got our libraries ready. Okay, so now notice that this is a little bit different as we are going to download both the tokenizer and the model from the Hugging Face hub. Okay, so I want an Albert-based version 2. Okay, and it says from pre-trained, so it means it's a pre-trained model, not likely fine-tuned. Okay, and one is the tokenizer, one is the model. So I'm going to run it. Okay. Oh, okay. It says that it needs something called sentence piece. Sentence piece is a module that provides algorithms for the tokenizer to use. And there's algorithms like sentence piece, BP. They're very amazing algorithms, okay? The best idea to explain this is that we don't actually have tokenizers of a word and a number. Instead, the tokenizer is numbers and something called subwords, which are basically like syllables. But they're not syllables like we create syllables in other languages, right? Instead, they are subwords like syllables that are created based on the frequency of occurrence of those. So in English, T and H occur a lot, like in the, right? But X and F followed by an F is not a common sequence. You see that? So that would not be a common syllable that the algorithm would create. And so again, the term is token, which are usually subwords, and they're more similar to syllables than they are to words. Okay? All right, so I need to install sentence piece, which is what's missing. So I'm going to go ahead and do that here. Then after this, we'll take a 10-minute break. So I'm going, pardon? Did I? Oh. All right, so I'm going to run sentence piece, which is the library that it says it's missing. Okay. All right, no errors, nothing, right? It says successfully installed. So I'm going to comment this out now. I'm going to run it. Okay, now I need to run this one, which is what gave me the error. Oh, so what is probably happening here is that I need to refresh the kernel or maybe even restart it. Sometimes these libraries persist. Okay, so I let's try it. Let's give it a minute. Okay, let's try this one. Are you guys trying this too? Does it work for you? Sometimes it can be a bit slow. Okay, it finished. Great. So that fixed it. All right, so we have sentence piece now. We have the model, which is, as I said, a BERT model, right? And we'll discuss the ideas behind BERTs in a future paper. So now let's take a look. And we're going to see how to use it. All right, so the text is, the cat is so sad, right? And basically remember that tokenizers just convert from text to numbers. So we give text to the tokenizer. It's going to give us an encoded input. And then we can run that encoded input through the model, which is the Albert model, and print out the output. Okay? So if you notice, the output of it is just a whole bunch of numbers, right? Because we need to decode it and all of that. But that just gives you an idea that we take text, convert it to numbers, go through the model, get out some numbers. All right, so now let's take a look at this here. So this is a more refined way of doing this. So I'm going to do Control Copy. All right, so now fill mask. So fill mask is a task. You saw me before I did, what was it? Answer questions, right? Something. Pipeline takes several tasks that you can give it, and then it'll try basically to use the model for that. It's a crude prompt engineering, if you think about it. It's very crude prompt engineering, but the seeds of it. GPTs and BERT still do the same thing. So fill the mask. So there's a specific format that is expecting. So if you remember last week when we were doing agents, we would say something like, make this prompt better, and we would give it the word prompt, and it knew how to fix it. So here we say fill mask with the pipeline. I wanted to use an Albert Bayes model, and then we call essentially we call this function fill mask, and we have to give it this in the proper format. So we give it the cat is so mask. And so wherever it, as in prompt engineering happens, wherever it sees that mask, it'll try to, it knows that it needs to do something for that. So now let's go ahead and run it. It's still thinking. I mean, it is a big model, right? Still. All right, there we go. So we have some answers here. So it provides in a pandas data frame, basically kind of like with the probability, or like the confidence that it has of what's going to happen. So it suggested this token ID. And so you can see it said the cat is so cute, the cat is so adorable, the cat is so happy, the cat is so funny, the cat is so affectionate. And basically that's kind of what it's doing. All these words are likely, right? But some are more likely than others. And in this case, cute seems to be the most likely. We can actually, with this, probably come up with examples of bias, right? So I can actually show you through this mechanism that there's inherent bias in these models. You asked about bias, right? Someone asked a question about bias, and you'll see that I can actually do that. So let's go ahead and take a look at another example here. So I did this example last year, which I thought was funny. So I don't know if you know, Chapo is like a drug dealer or something, criminal. And so I wanted to see the key thing is it may not know who El Chapo is, right? But so we run it. So it says, actually pretty smart, it says El Chapo is a figurative person, Franciscan, Dominican, Moroccan, Basque person, right? So at least it's picking up something that it's in Spanish. And so it's giving you that information. All right, let's try a few more. This one. So these, remember, this is an Albert model, which means it's a BERT model. So they do somewhat different work than the GPT, right? The GPT has always been generating text, whereas this BERT models are at least, what are they doing right now? At least I would call it fill in the blank. But this same idea could give us that it's going to give us some kind of a score, which is what I want to show you with regards to the reward models. So Anna is A. So we run this. So it says Anna is a wonderful person. Anna is a funny person. Anna is a good person. Anna is a nice person, and so on, right? So that's what it's doing. Let's take a look here. So here I was kind of playing with this. Let's try this one. Phil Mask, the nurse is examining the patient. Mask is writing down notes. Do you guys see that? So let's go ahead now, run it. What does it answer? The nurse is examining the patient. She is writing down notes. Do you guys see that? And then at position 4, it has he is writing down notes. So this is someone asked me about this idea of bias in text, right? That it captures the bias that humans have in text, captured it precisely, right? It just assumed that a nurse is female, right? And so, yes, there is bias and far worse bias in these large language models because they were trained on the internet essentially, right? So think about that. Does that make sense, guys? And removing this bias and all this is a very difficult problem, but there's ways, maybe through reinforcement learning, through human feedbacks, etc., that you can nudge the weights in a different way. Okay. That's more of I would call it like an AI assurance field. So nowadays, for you guys that like this, like security, for instance, there's cybersecurity, no, machine learning for cybersecurity, but there's also cybersecurity aspects of AI itself. And I think the term nowadays is AI assurance. So bias is a thing, toxicity is a thing. something called AI auditing, which essentially means explainability. Why did the model decide this? What was the underlying? And there's techniques for that and so on. But anyway, I wanted to show you this because it's a classic example. All right, let's see if I have another one. So, let's look at this one. Let's see if it still gives us the same answer. So here I wrote, the doctor is examining the patient. Mask is writing down notes. So if I run this one, notice that in first position, it said he is writing down notes. In second position, it said she is writing down notes, right? Why is this bias inherent in this text? Because when it looked at the internet, whenever doctor was mentioned in some context, it saw more he than she. That's the reality of it. It's the reality of it. But this shows evidence of how the models, because they've looked at so much internet, they have bias towards lots of things because they're essentially mimicking humans, right? That's what they're doing. I'm pretty sure that a Llama 3 or GPT-4, you ask it this question and it's gonna answer differently, but that's because they've done a lot of work on these things, right? And so, all right, we did that one. What's the next one that I have here? How many do I have here? All right, I seem to have a lot. Okay. Let's do this. So let's call it, we're done with bias there. We're going to look at other examples, but it's 3:12, right? It's 3:12. Let's take a 10-minute break. So let me, what is it? 7:12, sorry. I'm going to end this.